Mathematics is a beautiful discipline whose meaning has been lost to many people who engage with it. We try to change that. We believe mathematics is about ideas, and when those ideas come to life, a person becomes different. You will hear about some of those ideas from students themselves, and you will participate in trying to find some of that meaning when you partake in a problem. Our goal in teaching math is that what you are learning or thinking about has so much meaning that it becomes deeply a part of you. This leads a student to become an independent thinker and a creator of original thoughts. The students who are with us today have had this kind of experience in math class and outside of it. It is our jobs as teachers and learners to try to understand as best we can how a person thinks about a particular math question or problem, so we can enter into their thinking to help expand their thoughts, not to tell them how to think. This is part of our path to equity, helping every student reach their highest level of mathematical thinking and understanding.
For many people, math is challenging. But in my opinion, it's all about the way math is introduced and taught to you, and the style you as a student are able to better understand and comprehend it. I personally learn things visually, and the way I best work as a student and how math has helped me grow both as a student and a person is through visual learning. I once used to struggle in math, but it takes one good teacher to make you see math with a different perspective, or for them to help you out and support you. Most important, for them not to give up on you. I went from learning a different lesson, formula, skill, technique every single day in my old high school to taking things step by step and taking a closer look at math problems and knowing why it's even there in the first place. The math problem I was able to solve, you will be able to see the way I was able to take this math problem to the next level because of the way I am now learning math and being able to interpret it. When I first looked at this task, I was confused, and for a second thought, is this even a math problem? I had no clue this game would be related to quadratics. As the days went by, I kept analyzing this task, and it became easier and familiar. I remember I was in my social studies class one day, and out of nowhere, the equation to my math problem popped into my head, and I wrote it down as fast as possible before I could forget it.
We've been taught, oh, this is what high school is going to be like, regions, cram regions. It's always going to be tough like this. And I took 2 regions in middle school. It was algebra and earth science. I did really poorly at them. Like, I spent afternoons, mornings, weekends cramming, always practicing for what was going to be on it. But the moment I entered Bronx Collaborative, they barely say the word test or exam. We've been tasked, we're given a problem, and we're told to explore it. We're not given an answer. We're told to find it for ourselves. What else can we do with this problem? And having that type of approach, I was able to go somewhere with the problem I never thought I'd enter. I think it started off with like a simple algebra problem, and I went into number theory, which I didn't even know existed before doing that. And being able to struggle and explore a problem myself and proactively learn, not just in a classroom setting, but reading algebra books at home, outside of school, transporting back and forth, being able to delve into problems myself, explore a topic that I've chosen, I can apply it outside of high school.
I've been so fixated on the idea throughout my learning years that you just have to be given a formula, remember it, solve it, and then be done with it. When I was approached with proofs course last semester, I had no idea what proofs meant and how it would change my perception of critical thinking. In this math class, I was fortunate to engage in mathematical thinking that most students have not been exposed to. The process of collaborating with other students, being able to share my thoughts and strategies with my fellow classmates was very important to me. It not only gave me ownership of my ideas, but I was able to show and explain my thoughts to other people and be able to learn new ideas from other people. I was given math problems that required hands-on work and visualization. This forced me to take control of my own thinking and learning. When given the formula that was created by this famous mathematician, it was very distinct from any of the word problems that I have came across. The description of this problem was that this mathematician had to find the sum of numbers from 1 to 100. I was presented with the formula he came up with no instruction. I had to find the meaning of this formula while explaining my thought process. This experience came with some complications and failures, but my motivation to persevere ended up helping me create the theories and new formulas that I have explained in my PPAP.
When I came in this country 1.5 years ago, I knew nothing in math, even the basic things. I barely spoke English, and I was never in math class for my whole life. However, learning is a passion for me. I want to be the first person in my family to go to college. So I decided to come to the United States. Even though math is challenging, I have been able to accomplish great things in math in a very short moment. That gives me hope and encouragement that I can challenge myself to be better in math because I know how essential math is in our daily lives. 2 years ago, if someone came to me and told me one day I could think about one math problem for 2 months, that I would be able to write 20 to 30 pages about that math problem, I wouldn't even bother listening because I never even imagined that I could reach that level of math. I learned at math at ICHS has helped me to think mathematically, learn how to think outside the box in different strategies. When I was given a problem, I had to think in a new ways, research ideas I don't know before. I have spent 2 months thinking about one problem called walking to the door. It led me to thinking about the limit and idea of asymptote. I had to study fraction to be able to think about the problem I had. Through doing the problem, I got fascinated by the idea of finite and infinity. I was able to connect it to my life. Thank you so much.
First math class ever was a year and a half. Now we're going to get interesting, folks. We are all going to work on a math problem. We're not looking for answers. We just want to help everyone, show them that you have original thoughts and you can think for yourself also. In your folder, a set of 9 problems. You're going to choose the problem you want to work on, and your guide will be with you. I want each of you to spread yourself out in the room.
What's the mathematical whatever for this statement? What is the greatest amount of this nugget that cannot be purchased? Like, what's the...
If you want an exact operation, and I would say it's called modular arithmetic,
Modular.
which is a lot of adding. Right?
Okay.
It's just a big word for you're trying to add numbers together in a system.
Yeah.
That's what I thought too. I just start adding, see what I can make, see what I can't make.
Okay.
And modular arithmetic, for people who don't know, if I would describe it, it's like a clock. You know how a clock goes from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12? Instead of going 13 and on, it starts over again. And so when you apply that to math, you're looking at a sets of numbers that continue on in a system.
This is like when you add this together, you get the minimum amount of 35 moves. And this works for any variable that x is. And
So you looked at, you made some observation and you kind of saw that there is some
a pattern, yeah. And I also tried finding like the differences in the slides and in the jobs, because plug in any any number for x, it will work out.
How did you come up with the equation?
I found out the minimum amount of moves first. I tried finding like the differences, and since then I figured out that this had something to do with quadratic functions, and that it was gonna be like square root
6 different problems, but they were working together. That's why I was asking you, like, in one.
There was a lot of students working together, but like me personally, I like to get around the problem first and then collaborate. Yeah.
I'm sorry, I'm not sure I understand the question.
Okay, based on this one, from the speed, infinity and finite. So, based on the problem, do you see anything that is finite? Because you already mentioned that the door is something infinity, right? So do you see any sign of finite in this problem?
Any sign of
Finite, something finite.
Finite.
I don't. Not yet.
Not yet? Alright, think about it. Think about it.
Well,
That's the thing I'm looking for.
How can I?
How can you prove that? Based on the half that you're getting closer to the door, but you cannot reach it. If you can prove that.
The second one, you're going to have 250. The only one n is 1.
Very broad question is, what do you do in your classroom to help students to develop mathematical thinking?
You take the student where he is or she is, and you start asking them questions. You really listen to their mathematical thinking. You as a teacher believe that every student is able to go to another level, to think mathematically. I think that's like half of the success. And I go every day to school, happy to see my student, happy to listen to their thinking.
In my particular case, also, I think that if the teacher doesn't enjoy what they're doing it, the kids is not going to enjoy it. So for me, when I was doing the typical traditional math, I had the two students at public school, my two sons, and they went to the traditional high school where there is a lot of regent, there's a lot of preps, and they did it very well. But that was, what's the point? And I would say, if I'm doing something, let's say, what's the point I'm doing that? I really can get motivated. If I don't get motivated, I don't know how to motivate my student.
They will really persevere on their own because they want to accomplish something. I didn't know that everybody wants to solve problems. I didn't believe that people will be really want to solve problems. And you see, when students really get to the solution, they experience so many aha moments.
Although we are developing independent thinker, it's important for us not to forget that collaboration still needs to happen. Oftentimes, people think that math is just done independently, but great mathematicians work together all the time, share each other's thoughts with one another. Oftentimes, students do come in with these already preconceptions that they're gonna struggle in math because it's a math class. And I think that when they're able to see their peers also struggling with certain problems, they get to see that it's not only them. And I try to create that culture in my class. As a teacher or an administrator, I think there needs to be a shift in culture. I mean, you need to challenge yourself in terms of being open to this way of teaching. And it needs to be something that's not just happening in your classroom, because if you really want it to be impactful, I think it needs to be across like your math department.
And the final result is very rewarding because when they finish the problem and they will really believe in themselves and they will look at themselves differently. I couldn't do it here, but right now I know I'm a problem solver.
How do you create the environment and the needed structures that lead students to transform the way they think about mathematics and the way they think about themselves?
Main focus is that we're working on in the school is about student-centered classrooms and also students as independent thinkers. And as you see from the student that presented today, we're moving in that direction. We still have more work to do, but the math department knows and all the other departments know that they have the support from the administration to be able to do that work.
We have to hold ourselves accountable for our students' learning, and we have to be very clear about our culture and our vision for our students in all content areas. But in addition to that, to provide teachers with the supports that they need. And so we have coaching, we have intervisitations, we have the math exchange, we have students presenting their PBAT, but that process is such a reflective process.
You have to be open to new ideas and new ways of doing things and be brave enough to step away from the things that feel safe. One of the things that really challenged me was going into Ms. Kwame's classroom, and the students were sitting in a circle and they were debating this problem, and I was getting so antsy because I'm like wondering when are they going to get to the answer. I was the one who needed most coaching there. But you know, you're an administrator. All these pressures are on you. I graduated high school, you know, with great grades on my Regents exams, but I just knew procedural math. And then another experiment that they set up so wisely was that they gathered students at the competent, good, and outstanding levels for their PBAT presentations. And they had the teachers and the administrators sitting with the students doing exactly what you just did. And a student who had arrived testing between pre-K through third grade levels in his home language was running the group that I was sitting with, and he stumped us all. And at that moment I realized, yeah, this is the right thing to do. Because if the student can stump us, those of us who did everything the traditional way and only know procedural math, we need to allow the space for the conceptual understanding.
We wish you well on your journey of learning and celebrating and educating. Have a good rest of the day. Thank you.